Hello students, in last lecture we solved the example which is related to find out Euler's crippling load. In that particular example, the cross section of column is hollow circular section. Today I am going to discuss about example number 2 which is related to find out Euler's crippling load of a column which is rectangular cross section. So the data given in the example is a rectangular section of 250 by 350 mm of mild steel is fixed at both ends. So the column's section cross section is rectangular. Its breadth is 250 mm and depth is 350 mm. Breadth is 250 mm and depth is 350 mm. So B is equal to 250 mm and D is equal to 350 mm. And the end condition of column is fixed at both the ends. So end condition we will get, that is column is fixed at both the ends. So LE is equal to L by 2. Calculate Euler's load if length of the column is 4.8 meter. So length of the column from base to the top is 400 and 800 millimeter, that is specified by capital L or small l. Young's modulus, say capital E is equal to 200 gigapascal. So gigapascal is converted into Newton per mm square by using unit conversion. So you have given 200 gigapascal. If you want to remove G, say giga, you have to put 10 raised to 9. ગીગા ને દૂર કરવા માટે તમારે ગીગા બરાબર 10 raised to 9 વડે 200 ને મલ્ટીપ્લાય કરવી પડશે. પાસ્કલ, that is as it is. Next, 200 into 10 raised to 3. Say 1 Pascal is equal to 1 Newton per meter square. So it is 200 into 10 raised to 9 Newton per meter square. Now 200 into 10 raised to 9 divided by, you have to convert this meter into millimeter. So put the 1 meter is equal to 1000 millimeter. So 1 meter square, so 1000 millimeter square. So unit is Newton per millimeter square. Here is 10 raised to 6 in denominator and numerator has 10 raised to 9. By solving this equation you will get 200 into 10 raised to 3 Newton per mm square. So it is a 2 into 10 raised to 5 Newton per millimeter square. So 200 gigapascal is equal to 2 into 10 raised to 5 Newton per mm square. Now move forward. You have to find first capital I, moment of inertia, is equal to BD cube by 12 for rectangular cross section. So substitute the value of B 250, D 350 cube divided by 12. By solving this equation you will get capital I, moment of inertia, is equal to 893.23 into 10 raised to 6 millimeter raised to 4. This is the capital I, say moment of inertia for rectangular column. Both ends of the column are fixed. So LE is equal to L divided by 2. L is 4800, that is divided by 2. You will get 2400 millimeter. Now substitute the value of I, moment of inertia, LE, effective length of column, in Euler's equation, that is PE is equal to pi square EI upon LE square. Pi square E is equal to 2 into 10 raised to 5. I is equal to 893.23 into 10 raised to 6 divided by LE is equal to 2400 square. multiply all the terms in numerator and add one more term over here, and that is numerator is divided by denominator, and you will get the solution, that is Euler's crippling load PE is equal to 306.10 into 10 raised to 6 Newton. That is the answer of your example number 3. The next example number 3 is a rectangular column, and both end condition is both ends of the column are fixed, but you have to find least radius of gyration, slenderness ratio as well as Euler's crippling load. તો અહીં આ રેક્ટેન્ગ્યુલર કોલમની બી આપી છે, ડી આપી છે અને કોલમની લંબાઈ 6000 મિલીમીટર આપી છે તથા કેપિટલ E મોડ્યુલસ ઓફ ઇલાસ્ટિસિટી 2 into 10 raised to 5 ન્યૂટન પર mm સ્ક્વેર લેવાનું છે. સો મિનિમમ રેડિયસ ઓફ ગાયરેશન છે કે મિનિમમ ઇઝ ઇક્વલ ટુ under root I minimum divided by A. That is the equation that we have solved in the previous lecture. So you have to find minimum radius of gyration K minimum. To find out minimum radius of gyration, you have to find out I minimum and cross sectional area of column. So I minimum is the minimum value of Ixx and Iyy. Ixx is the moment of inertia about xx axis, that is equal to bd cube by 12, and Iyy is equal to moment of inertia about yy axis, that is db cube by 12. So by solving this equation, substitute the value of bd in this both the equation, you will get the moment of inertia. Ixx is equal to 450 into 10 raised to 6 mm raised to 4, and Iyy is equal to 200 into 10 raised to 6 mm raised to 4. Among these two, Ixx and Iyy, minimum is 200 into 10 raised to 6, that is Iyy. Take minimum value of Iyy in this equation to find out minimum radius of gyration. Cross sectional area of rectangular column is B into D. Column નું ક્ષેત્રફળ પહોળાઈ ગુણ્યા જાડાઈ થશે. 200 into 300, you will get 600 into 10 raised to 3 millimeter square. Substitute the value of Iyy and A in this equation, you will get minimum radius of gyration K minimum is equal to 333.33 millimeter. So next you have to find slenderness ratio. Say lambda minimum. Minimum slenderness ratio, the formula to find out slenderness ratio, that is effective length of the column divided by K minimum. Slenderness ratio is the ratio of effective length of column and radius of gyration. So substitute the value. Le is equal to L by 2, 6000 divided by 2, you will get 3000 millimeter. 3000 divided by K minimum is equal to 333.33. Divided these two terms, you will get the answer, slenderness ratio is equal to 9. Next we will find last one, that is to find out Euler's crippling load. PE is equal to pi square EI upon LE square. Substitute EI and LE, you will get the final Euler's crippling load, that is equal to 98.69 into 10 raised to 6 Newton. Next, Euler's formula is used to find out the Euler's crippling load of the column which is long. But if you have a column which is either long or short, that is at that time you have to use Rankine's formula to find out crushing load. Crushing load means in short column is failed by crushing. So in this particular equation, you have to use Rankine's formula to find out crushing load. And Rankine's formula is used to find out both long column as well as short column that is specified in the limitation of Euler's buckling or crippling load. So if column is short, you have to use Rankine's formula to find out Rankine's crippling load, Rankine's crushing load. P is equal to crushing load. R is for Rankine is equal to sigma C into A divided by 1 plus alpha into LE divided by K square. Here the sigma C is the crushing state which is given in the example. A is the cross sectional area of the column. સિગ્મા સી એ કસિંગ સ્ટ્રેસ છે અને એ કોલમના આડછેદનું ક્ષેત્રફળ છે, સિમ્પલી ક્ષેત્રફળ છે. આલ્ફા જે છે ધેટ ઇઝ અ રેન્કિન્સ કોન્સ્ટન્ટ, રેન્કિનનો કોન્સ્ટન્ટ છે અને જે એક્ઝામ્પલમાં આપ્યું હશે. એલી યુ હેવ already know that is effective length of column, K is radius of gyration. So you will put all the element in this equation of Rankine's formula and you can find out Rankine's crushing load. And here I am closing my chapter and give you one assignment that is related to solve as an assignment or tutorial. So important question that is given in the listed over here. Say 7 question that is asked in either 2 marks, mostly in 2 marks, or one of them is 3 marks. So you have to solve by using all the PPT that is given in previous lecture. You can solve all the question and write in your notebook, as well as other 7 examples which are asked in the last 3 years of GTU examination. So you have to solve these 7 examples so that you have clear that you will solve the your next examination of strength of material. આ બધા એક્ઝામ્પલ છેલ્લા 3 વર્ષમાં પૂછાયેલ છે. આ 7 એક્ઝામ્પલ તમારે સોલ્વ કરવાના છે અને એ અસાઇનમેન્ટ તરીકે તમારી નોટબુકની અંદર લખવાના રહેશે. જો કોઈ પ્રોબ્લેમ આવે થિયરીના સવાલની અંદર as well as in an example, you can freely contact to me by using this mobile number 9978741819. So this is the end of this chapter, that is column and strut. Thank you very much for viewing this lecture and prepare for your examination. Thank you very much.